Okay, this is still 11-3, simplifying or solving radical equations. And I just want to clear up something before we move on from example 4. So in example 4, you're finding those two different solutions, and then you have to figure out which one actually works and the other one doesn't work. The reason that -3 didn't work was because when you take the square root of 9, that's 3. And I know that there are times when we have a positive and a negative answer for that. That's only like, for instance, if you were doing x squared equals 9 and you were square rooting both sides. So when you square root both sides, you end up with a positive and a negative answer because this x squared, that could be -3 squared or it could be +3 squared. And so then when you take the square root of it, so that way x is a positive or a -3. And again, that's because you could plug in a +3, 3 squared is 9, the square root of that, or you plug in a -3, -3 squared is 9. And so either way, and so that's when you get a positive or a negative answer. Also with our quadratic formula, you get a positive or a negative because that's built into your equation. X equals -b plus or minus the square root of, etc. So it's built into your equation where you always have a positive and a negative answer. But in this case, only one of them works because you're taking it at face value. We're not adding any plus, minus, any of that. We're simply taking it at face value. So the -3 did not work and the 4 did work. So let's look at a couple more of those just to cement that idea. So this first kind of problem says, tell which solutions, if any, are extraneous. So here, we just want to figure out which one of these is the one that does not work. Remember, the extraneous solution is the one that does not work. So we're just going to plug in both of these. I'm going to try -4 and I'm going to try +3. So I have the square root of 12 minus, instead of n, we have to plug in that number. 12 minus -4 equals -4. Minus a negative is plus a positive, so it's the square root of 16 equals -4. The square root of 16 is 4, and 4 does not equal -4. So our extraneous solution would be -4. And we can try 3 and see how that works. So we have the square root of 12 minus 3 equals 3. 12 minus 3 is 9. The square root of 9 equals 3. And square root of 9 is 3, and 3 does equal 3. So our extraneous solution would be -4. So in this kind of problem, when they want you to tell which one is the extraneous solution, you're choosing the one that does not work. So your answer then is n is -4 because that's the extraneous solution. It's the one that does not work. But on the second kind of problem, they want you to solve the radical equation. When they ask you to solve, that means pick the answer that does work. And then check your solution. Since we're going to get two different solutions, we have to check to see actually which one does work. So our radical is isolated. We want to square both sides first. 2y squared is 4y squared. You have to square the whole thing. 2 squared is 4, y squared is y. Remember that from chapter 8. Everything inside the parentheses has to be raised to the second power. Squaring this radical just cancels it, so that equals 5y plus 6. We need everything on this side, so I'm going to subtract 5y and subtract 6. So I have 4y squared minus 5y minus 6 equals 0. And then we have to factor in order to solve. Since we have a trinomial here with a y squared and a y and a constant, the only way to solve is to factor. And in this case, since we have that coefficient in front of y squared, we have to use our grouping or FOIL method, but mainly we use grouping. So first we want to look, is there a GCF? Not for 4, 5, and 6, so we want to find the product of AC, which is 4 times -6, -24. Then find the factors of AC, or -24, that add to BB, so the sum of -5. So I have a negative times a positive. We want the negative to be bigger, so we get a negative here. So we could do 1 and -24 doesn't work. 2 and -12 doesn't work. 3 and -8, when you add those, you get a -5. So we're going to rewrite our equation using 3 and -8. Leave the first and last terms alone. 4y squared plus 3y minus 8y minus 6 equals 0. So remember, we're rewriting that middle term. Plus 3y minus 8y is the same as -5y. And then we simply group. So I have the first two terms and the last two terms. The GCF of 4y squared and 3y is just y. Y times 4y is 4y squared. Y times 3 is 3y. Then here we have to pull out a negative to get rid of those negatives because these are both positive. So I'm going to pull out a negative 2. Negative 2 times 4y is negative 8y, and negative 2 times 3 is negative 6. And then we create our two binomials, pull out the GCF of 4y plus 3, that's the GCF, times what's left, y minus 2, equals 0, and then split those up and solve. 4y plus 3 equals 0, or y minus 2 equals 0, so subtract 3 from both sides. 4y equals negative 3, divide both sides by 4, y equals negative 3/4, or add 2 to both sides, y equals 2. So it's one of those is our answer. Remember, we need to plug that into our original equation to check it, so I'm going to check it over here. And let's see, our original equation was 2y equals the square root of 5y plus 6. So we want to try both of those solutions that we found. So I'll try negative 3/4 first. So I have 2 times negative 3/4 equals the square root of 5 times negative 3/4 plus 6. 2 times negative 3/4, remember it's over 1, so 2 times negative 3, that's negative 6 over 4, equals the square root of 5 over 1 times negative 3/4. 5 times negative 3, that's negative 15 over 4 plus 6. So I have negative 6/4 equals the square root of, what is negative 15/4 plus 6? I'm just using my calculator. I get 2.25, and negative 6/4 as a fraction is negative 1.5. The square root of 2.25 is positive 1.5, so those are not equal to each other. Therefore, negative 3/4 does not work. Let's check 2. So I have 2 times 2 equals the square root of 5 times 2 plus 6. 2 times 2 is 4 equals 5 times 2 is 10 plus 6 is 16. The square root of 16. 4 equals the square root of 16 is 4. 4 does equal 4. So in this case, our only answer is 2. So remember the difference in these directions. One asks you to solve, and so therefore you're finding the answer that does work. The other asks you to tell which solutions are extraneous, so you're finding which answer does not work. Okay, let's move on to that last example, example 5. These are no solution problems, and we'll see why they have no solution. So again, we need to isolate the radical. Subtract 8 from both sides. The square root of 3x equals negative 6, and then square both sides. So we want to get rid of that radical. So I have 3x equals negative 6 squared is positive 36. And then divide both sides by 3. So x equals 36 divided by 3 is 12. Now, again, we need to make sure it works. So let's plug it in to see that it works. The square root of 3 times 12 plus 8 equals 2. 3 times 12 is 36. The square root of 36 is 6 plus 8 equals 2. 6 plus 8 is 14, and 14 does not equal 2. So this means that this solution, the only solution we got, was extraneous, meaning that it doesn't work. So that's why you always want to make sure to check to see if the solution you got actually works. So this solution is extraneous, therefore there actually is no solution at all. The only solution you got is the solution that doesn't work. So the answer is no solution. Let's look at one more like that. Again, we want to isolate the radical, so I have 8 minus the square root of 2n. So I would subtract 8 from both sides first. Negative square root of 2n is equal to 12. And then I want to get rid of that negative. So in order to do that, either multiply both sides by a negative 1 or divide both sides by a negative 1. So you have the square root of 2n equals 12 divided by negative 1 is negative 12. Once you've isolated your radical, you can then square both sides. to get rid of the radical. So I have 2n equals negative 12 squared is positive 144. Divide both sides by 2, and n equals 72. Okay, let's check our solution. We want to make sure that our solution actually is a solution, that it's not extraneous. So I have 8 minus the square root of 2 times 72 equals 20. 8 minus the square root of 2 times 72. 2 times 72 is 144. The square root of 144 is 12 equals 20. 8 minus 12, that's negative 4, and negative 4 does not equal 20. Therefore, the only solution we found is an extraneous solution, and so there is no solution. There's no solution that actually works for our problem. Okay, so remember, just isolate your radical first, and then once you've done that, you can square, and you have to square both sides, but you can square to get rid of your radical because the opposite of square rooting is squaring, so they cancel each other out. Just make sure you do that to both sides, and then solve like a regular algebraic equation.